All right, here's a quick experiment. We're going to be looking at two disks that rotate down an inclined plane. Now these two disks, one has the mass separate, but in the second setup we're going to move the masses towards the center. Now you'll actually notice there's a difference. It's the same two disks except one of them has the masses pushed towards its center of rotation. And as you can see, there's a difference. And just in case you couldn't see the difference, let's watch that again, but in somewhat slow motion and with double vision. As you can see, the one with the center of mass located closer towards the center races ahead of the other object, whereas when it's separate, it doesn't. Now that means something. What it means is there's something going on. This is called rotational inertia, and it's the resistance of an object to rotation or change rotation. And basically the rule is, the further the mass is away from the center of rotation, the greater the rotational inertia. It's one of the reasons why tops look the way they do. You have all the mass kind of pushed out towards the edge, so it has an ability to spin longer. It has a greater resistance to slowing down. And it also allows us to better understand things like, I don't know, the tightrope walkers, those guys that actually go across the high wires and from building to building. In fact, the video you're looking at right now is actually the same guy that walked between the Twin Towers in New York City. And he actually apparently walked back and forth 8 times back in the 70s. Now you notice the stick he's using has a lot of the mass distributed away from his axis of rotation. That allows him to have some stability as he's walking across. Now Dorothy Hamill is actually going to make a spin, and as she does, she's going to bring her mass in and reduce her moment of inertia. And as you can see, she spins faster. So that's basically the idea of moment of inertia.